Okay, we're going to do another example, which is under the heading the normal approximation of data. Or maybe for data. All right, so let's see. Here we have that the heights of women age 18 and over in a study which is called the Haynes 5, which is a study of the height of women it was done in 2003 in the United States, averaged 63.5 inches. So this is the average height of women in the United States in 2003, according to the study, with standard deviation of 3 inches. All right, what we're going to do is we're going to use the normal curve to estimate the percentage. Estimate is really important because we're saying that the distribution of heights is normally distributed, but that's it doesn't necessarily have to be exact. I mean, there's a question of how many decimal places when we use this model we should use. So okay, so we're going to use the normal curve to estimate the percentage of these women with heights over 59 inches. Okay, now so 59 inches is below the mean. And I can do it quickly in my head. 63.5 minus 59, that's 4.5. So how many standard deviations is 4.5? Well, 3 goes into 4.5 1.5 times. Okay, let's just talk about this. So first of all, we can do this optional thing, which is find standard units. So if I have x is equal to 59, mu is equal to 63.5, and sigma is equal to 3, I can use this formula, which is z equals x minus mu over sigma. So that makes 59 minus 63.5 over 3, which gives negative 4.5 divided by 3. 3 times 15, the reason I could do that in my head is 3 times 15 is 45. So there's a 15 there, and I have to get the decimal right. All right, so the picture we're looking at in standard units is as follows. here I have negative 1.5, and I'm looking for the area for women over 59 inches. So we're looking everything to the right. So the thing is that whether it's exactly 59 and above or above 59 inches, it's going to give the same area, because that line corresponding to the exact number of 59 inches corresponds to negative 1.5. That line has no area. So here we have the normal curve. Now, I like the idea of being able to use the empirical rule to answer this question, but I know for the empirical rule, values between negative 1 and 1 standard deviation and negative 2 and positive 2 standard deviations. So I don't have anything for negative 1.5. I could look that up and memorize that. If I did this enough, maybe that would be something I'd be interested in. Maybe I'll do that. But I could find an estimate. I could say, well, but let's not do that. Okay, it's just about to get off on a tangent there. But what we're looking at is that this value of 59 inches is 1.5 standard deviation below the mean. So now I'm moving on to the TI-83 calculator. And I'm going to put, this time, inches. So the average 63.5, so this is all inches. And we're looking at 59 inches over here, which it was out of my curiosity. I wanted to see, how many standard deviations that is below the mean. And so that's why I made that calculation, especially since to find out it's 1.5 below. It was not that hard for me. So I just did it. If something's really difficult, I would think, well, maybe I'm too lazy to do that. But I think I can do that. I mean, I did it. Okay. But I'm using the TI-83 calculator to find this area, because we're looking for the proportion of the population which is above 59 inches. So I use second distribution, and I use 2, which is normal CDF, and then I enter. Okay. And then I get to, not PDF, CDF. Then I get this on the screen, normal CDF. And what I need to do is I need to put the left endpoint, which is 59. And I need to put the right endpoint. Okay, so this is sort of a weird thing that, in fact, there is no right endpoint. So some calculators work it out that you just, let me just not talk about what other calculators do and just stick with this calculator. So this calculator requires that I have a left endpoint and a right endpoint, but this in fact goes on to infinity. However, I mean, the curve keeps going on and on and on, and it lies above the horizontal axis. However, as we go to the right, the area below is so small. So what we do is we just put a really big number in here. Now you could think about, well, what's big? And you could start thinking about, well, in terms of 3 standard deviations, probably 1,000 would be really big. But what I do is I just put the biggest number I can enter on the calculator. And to do that, I put second EE 99. And this means 10 to the 99 power, which is, it depends on what you think is big, but anyway, that's the biggest number the calculator is going to hold. It's 1 with 99 zeros. And then, okay, so we've done that. I showed that in another video too. So then we put the mean here. That comes next, and if you get the wrong order, then what happens is, unfortunately, the problem, you get the wrong answer. So it seems sort of petty or trivial, but that's how computers work, is you have to get that exactly right. So this, this calculator is a computer. So you have to get it exactly right, and if you get the order wrong, then it's not going to be correct. You have to give them exact. You have to give the exact directions. So, okay, now I'm going to do this on the calculator, and once you get going on this, it's not sometimes not so bad. All right. So, okay, let me just point out before I tell you what the answer is, leaving you in suspense. If I were just doing everything above the mean, I get 50%. As the picture shows, this is going to be more than 50%. Okay, so the answer is it's a number that's greater than 50%. The thing is that I don't feel that just because I'm using a calculator that I know it's right, because I am so familiar with me punching in the wrong numbers by mistake. It's a very common thing, and I read books about when you're doing real stuff with data. You're actually using data. Be careful for that part that you're doing manual entry. That you're actually putting in numbers, because that's something where you can make a mistake. By the way, I don't know if I'll write it down, but okay. So by the way, if you want to bring up, I've talked about this before on your calculator. If you want to bring up, so here's what my calculator looks like. If I want to do another problem that's very similar, where I'm just all I need to do is edit it and change the numbers a little bit. What you can do is second, I guess I'll write it down on the paper, but anyway, second entry. Second entry will bring up the same thing and then that you had just before. Now, if you want to get like what you had 2 times before, you press second entry again, or 3 times before, second entry. I don't know how many times where you can bring it back to what it was before. And so then you can go in and you can toggle to where you need to be. All right. So maybe I won't write that down because it'll sort of make a mess of these notes. But let me start at the beginning then. What was the idea? There's a study that gives the average and the standard deviation. This shows you the standard deviation is very important for really to understand what's going on. The average height for women is according to the study 63.5. By the way, that's 5'3.5". Okay. And then the standard deviation is 3. Now this person here is, well, I don't know if it's a person, but anyway, they're asking how many people are taller than 59 inches. 59 inches is 4'11". Okay. So, and this is for women. All right. So what you can do is just, by the way, you might be interested, how many standard deviation is that below the means? What you can do is you can take 59 and you can punch in this formula for x is 59, put in the average and the standard deviation, and you get negative 1.5. So in standard units, this shows us that our number of 59 inches is 1.5 standard units or standard deviations below the average. Okay, but I'm going to look at this picture here and I'm saying, well, what's this proportion above 59%? We look at the area under the curve. Now to do this, what I use the calculator. Let's put this all in the calculator and give me the answer. I don't really have a way of checking, but I don't think that number is absurd because it should be more than 58%. I could also check a little bit by thinking about the empirical rule and what I would expect. I can figure out that to the left of -1, well, I mean, I'll start getting into it, but I can use the empirical rule to find the area to the left of -1 and the empirical rule to get the area left of -2. And from there, I can figure out some things to see whether I think this is the right answer. Okay, but this is the proportion of the population that's of women in the United States that are 4'10" or taller.